Alright, solving rational equations. While we do this today, please make sure that in each problem you are identifying the undefined values. These are known as restrictions of the domain. Remember, restrictions in the domain of a rational function are the places where the denominator equals 0. When it comes to problems that have more than one restriction, such as in question number 3, you will have two undefined values or two restrictions in the domain. Now, the way that we're going to solve problems like these today is by finding a common denominator and multiplying that common denominator across the numerator of every fraction involved in the function. The purpose for doing this is to remove the denominator of the fraction, making the rational function easier to solve for x. So in this problem, the common denominator is 3. So above this, I'm going to go ahead and write out my common denominator of 3. For each part of the fraction, I will cancel the part of the common denominator that is canceled by the actual denominator in each individual fraction. Now, because it's 3 every time, of course it cancels out. X plus 1 plus x minus 1 equals 4. The resulting equation is much easier to solve for x, and that is the purpose for actually multiplying the common denominator throughout the numerator of every individual fraction. As with all rationals, please make sure you check for extraneous solutions by plugging in every answer you get to the original problem and seeing if it works. 1 plus 2 is 3, 3 over 3 is 1, 2 minus 1 is 1, 1/3 plus 1 is 4/3, checks out, it's not extraneous. So the common denominator for number 2 is 5 times y plus 1. I'll use that common denominator and I'll multiply it through the numerator of every fraction in the function. Now what I'll do is I will cancel the portion of the common denominator that cancels in every individual fraction. I'll write the resulting problem without denominators, making it easier to solve the problem. Distribute 5y minus 25 equals 3y minus 3. Plus 3. Now I'm going to move my numbers. 3y will come over here because it's smaller. 25 will go to the other side. And I get 2y equals 28. So y equals 14. As with all rationals, please check for extraneous solutions. Now, because 2 is the first time we have a denominator that has a variable in it, we'll go ahead and identify those undefined values quickly. We'll go ahead and do that through each one of these example problems so you get in the habit of seeing that, and later on in some of the practice problems you'll see that that actually plays a role. Okay, so this y plus 1 represents the restriction in the domain. The value of y that makes this equal to 0 is -1. So y cannot equal -1. If you don't remember that or you can't see that for certain problems, then remember it's very simple to write this small equation and solve that one for y. Question number 3. We're going to look at this and we're going to determine what our common denominator is. Remember, the common denominator is 1 of every denominator that is down there. So that's going to be 2, x minus 1, x plus 2. I'm going to use that to multiply across each fraction, x minus 1, x plus 2. And I'll go ahead and cancel out in each fraction the part that cancels with the existing denominator. I'll simplify the remaining parts. 2x plus 4 plus 2x minus 2 equals x squared minus x squared plus x minus 2. I'm going to simplify my numbers, giving me 4x plus 2, and I'll go ahead and move those two numbers using their opposite operation to the other side and combine like terms. Minus 4x minus 2, so I get 0 equals x squared minus 3x minus 4. I'm going to factor the remaining answer, and I get x minus 4 times x plus 1. I'm going to solve each one for x, and I get x equals 4 and x equals negative 1. I'm going to check for extraneous solutions by plugging them back into the original problem, and they both check out. Neither is extraneous. Okay? We're going to identify in this problem your undefined terms, and in the first fraction the undefined term is 1, so x cannot equal 1. In the second fraction the undefined term is negative 2, so x cannot equal negative 2. In question number 4, you'll notice here that we have a 3 and a 6, which means to use both of them in your common denominator is using too much. So we're going to just use 6 times x minus 2, because you'll notice by dividing the first fraction by 6, you remove the 3 from the denominator. That's just a little piece of advice. Make sure you don't get too much in there. If you have two numbers that have the same GCF, then you can use the larger of the two. Alright, so with our common denominator being that, we're going to reduce the 6 to a 2, as well as cancel out the x minus 2. Alright, so now we get 2 times x plus 1 equals 5x times x minus 2 plus 6. I'm going to simplify by using distribution. 2x plus 2 equals 5x squared minus 10x plus 6. Moving the 2x and the 2 to the other side of the equation and combining like terms. 5x squared minus 12x plus 4. Now I'm going to factor. I need the two numbers that multiply together to make 20 and add up to negative 12. That's 10 and 2. So 5x squared minus 10x minus 2x plus 4. How I'm going to split this? 4-term grouping gives me a GCF of 5x in the first group, x minus 2. Negative 2 is the GCF of the second group, x minus 2. My factored form is 5x minus 2 and x minus 2, which means the solution to this problem is x equals 2/5 and x equals 2. As always, you want to check for extraneous solutions by plugging these back in. But instead of doing that, what you would want to do first is identify your undefined terms. And by doing that, you would notice that the second answer is extraneous, which means that 2/5 is your answer, not 2. Last two examples on this page. Your common denominator, it looks like it's all three of these, but if you factor out this binomial, you'll notice that this is a combination of both the first two denominators, so your common denominator is simply going to be x minus 3 times x plus 3 times x minus 1. believe in your notes it is an X here rather than a 1, so I need to make that change before moving on. X times X minus 1 plus X plus 3 equals 4. X squared minus X plus X minus plus 3 equals 4. I'm going to bring the 4 across, combine like terms, and I get X squared minus 1 equals 0. That's the difference of squares, X minus 1 and X plus 1, which means my solution to this problem is X equals 1 or X equals negative 1. We go back to the original problem, determine your undefined values. X cannot equal negative 3. X cannot equal positive 1, so that makes this extraneous. Negative 1 checks out once you plug it back into the original problem, and that your solution is only negative 1. Your common denominator here is going to be 18a squared. So I'll go ahead and multiply out that through the entire problem. This reduces to 2. This reduces to 9a. And this a squared cancels out, leaving it 18. Moving the 18 to the other side, we'll go ahead and factor this out. We need the two numbers that multiply together to make 36 and add up or subtract from each other to make 9. That will be 12 and 3. 2a squared plus 12a minus 3a minus 18. 4-term grouping. The GCF of your first group is 2a. Your second GCF is going to be negative 3. Making your factored form 2a minus 3 and a plus 6. Your two solutions are a equals 3 halves and a equals negative 6. The restrictions on the domain are x cannot equal 0. Checking for extraneous solutions, neither of these two are extraneous. They both check out once you plug them back into the original problem, and that is the solution. Please take the time now to solve questions numbered 7 and 8 on your own. See if you can come up with your solution and be ready to share that tomorrow with the class or with your group. Make sure that you understand what you're looking at before we move on in the lessons. The last example we're going to go over today is question number 9. I went ahead and filled in the table values. Now the way that you're going to want to find these table values is you're going to first want to put the left side of the equation into y1, put the right side of the equation into y2. When you graph it, you're going to be able to look carefully and you're going to be able to see the number of solutions that occur. You're going to want to identify those solutions because then you can go to your table values and determine where the intersection points are based on the estimated intersection points in the graph. So that's how I determined that negative 3 to 3 and negative 4 to positive 4 are good values to use in setting up these two tables. It does take some observation from the graph to determine where the tables should be set. So please keep that in mind as you do question number 10 in just a minute. So now we're going to identify the place in the tables where the values of the first table are identical to values in the second table. Your first solution is -3, -2, and your second solution is at 3, 1. So you use those values to determine where your solutions lie, and then you can go over and graph your graph by filling in these points on your coordinate grid and then draw your curved line through it. One thing of note is when we get to graphing in a few days, you'll notice that the graph approaches but does not touch the number -1. The reason why it does that is because the undefined value of the graph is -1. That means there is a vertical asymptote at that location. Okay? We'll get into more detail with that when we get into graphing rationals, but that is an observation that you should be able to make just by looking at these examples and the problems that you're doing in your practice. Take a look at question number 10. Do the exact same thing. Now when you put this into your calculator, it is very important that you use parentheses appropriately. So please keep that in mind. You want to put parentheses around the entire numerator and around the entire denominator. I want you to experiment with that and determine what your correct answer is, so that tomorrow in class we can have a discussion about what it is that needs to be placed in parentheses in order to get the appropriate solution here. Okay? So definitely do some investigation here to make sure that you understand clearly how to put these rational functions in your calculator so that it will give you the right answer, because there's ways to do it correctly and incorrectly. Be ready to discuss that tomorrow in class.